Today we are going to talk about our senior design project, remote controlled submarine. Our aim and focus was to build a submarine that can gather data underwater and controlling it wirelessly. Our objective here is to have a live video feedback or live video streaming, and to sense temperature, pressure, and from pressure we can sense the depth. And we reached our aims, and now we are going to talk about our subsystems.
We have 6 subsystems. We have wireless communication, thruster control, power distribution. We have live video streaming, sensor data acquisition, body design.
We're going to talk about the first subsystem, that's thruster control. As you can see from our body, we have 6 thrusters mounted on different sides. These 2 are for the vertical motion. They are mounted vertically. 2 thrusters mounted horizontally for the forward, backward, left and right. This is for strafing effects, and the last thruster is for tilting the submarine. So as you can see from here, we have 6 ESCs connected to the power distribution board, 3 on the top and 3 in the bottom. And these are connected to all thrusters, and which have been sealed because so that no water goes inside. And through these ESCs, these are connected to the connectors A and B of the Myrio, and we can vary the duty cycle. Vary the duty cycle by using the PWM blocks in LabVIEW. Set the frequency of the thrusters at 50 Hz, and we vary the duty cycle ranging from 0.075 to 0.095 for the forward, and 0.075 to 0.055 for the reverse. So basically how we achieve control over the submarine is by placing the thrusters in positions where we get maximum control from minimum thrusters. So as you can see out here, if we vary the duty cycle of these 2 thrusters, then it lifts vertically up. If they go in opposite directions at the same time, they will go forward, upwards. And if they go in the opposite direction in the other direction, then they go down. Similar for the thruster in the back, to tilt it. If you send it forward, it will tilt upwards. If you send it the other way around, it will tilt downwards. So these 2 thrusters, basically, if they move in the same direction, they will turn either right or left. And if they move in the opposite direction, they will either move forward or backward. And the strafing thruster, the thruster below, is used seldomly, only if there is lots of waves in the water. Since we didn't encounter too many waves in the swimming pool, we didn't have to use this that much, but it adds in additional functionality to the submarine. So I'm going to talk about the 4th subsystem in our scene design project, that's sensor data acquisition. So we have 2 sensors, 2 primary sensors in our project. One is the temperature sensor, the other is the pressure sensor. From the pressure sensor, we can measure depth, P is equal to gamma h, and we have lots of equations given in the data sheets to convert the binary logic that's given to the Myrio to intelligible data. Connect the sensors to the I2C ports of the Myrio, and after we get the data in binary numbers, we convert that to intelligible numbers. How we do that is we specify a slave address that's provided in the datasheet, and once we get the data, it is up to us to implement any equations that are appropriate to our system. We completed all the subsystems as we proposed in our specifications, and we had successful tests, and now you will see the video.